Hi, this is DJB Mathematics, and what we're going to do in this video is we're going to solve some basic trigonometric equations using the cast diagram method. This video is part 2 of a series, so if you want to know a bit more about what a cast diagram is and what it shows, look at part 1 in this series. In this video, we're going to look at equations with a positive right-hand side. And I'm going to solve 3 trigonometric equations, one each for sine, cos and tan. Okay, off we go. So the first example is asking us to solve the equation sine x equals 0.7 on the interval 0 less than x less than 360 degrees. So that tells me it wants answers in degrees, and it wants all the possible values between 0 and 360, where sine of x is 0.7. Okay, and wants me to give my answers to one decimal place. And I'm going to follow this little recipe that I've laid down over here, and that will get me all the answers. Okay, all the solutions to that equation. First step, rearrange the equation to get sine, cos or tan on its own. Well, we've got sine x on its own here, so that's already been done. The question is like that already, so we're fine. Next step is use the sine inverse, cos inverse or tan inverse button. Obviously sine inverse to deal with a question involving sine. And what you put into sine inverse is you put in the right hand side. Okay? Remember, for the time being, we're only dealing with positive right hand side. So I need to get that value from my calculator. Okay? Clear that. So make sure you're in degrees mode, and what I want to do is get the inverse sine of 0.7, which to one decimal place is going to be 44.4 degrees. Okay, so now that's done to get the information I need out of my calculator. Now it says to find all the solutions I need to draw lines in the correct parts of the cast diagram. Where are the correct parts? Well, 0.7 is positive, which means that value of sine x can only occur when sine x is positive. And that means we're either in the all section, where all 3 are positive, or in the sine section, where only sine is positive. But we can't be down here in T or C. It's not possible for sine to be positive there, as we saw in the previous video. So let's draw some lines in the all section and the sine section. And let's mark on the angle. It says measure your angles for now from the horizontal. So I'm going to mark on 2 angles here from the horizontal. So there they are. Okay? And the size of those angles is the same as this value here. They're 44.4. So that's an angle of 44.4 from the horizontal. And so is that. That's an angle of 44.4 from the horizontal. Okay? So those blue angles are both 44.4. Now let's move on. Now that we've drawn our lines, let's measure our solutions. Okay, so what we want now are the actual values. There are going to be 2 of them, one for each line on the cast diagram that we've drawn. So I'll separate those with a comma. And what we do is we measure now anti-clockwise from 0. So we go from 0 up to this line. Well, I said before that this angle here is 44.4, so from 0 up to there just gives us the answer that our calculator gave us earlier. So one possible value of x is 44.4 degrees. But now we have to find the second place where that happens. So what we do is we start at 0 again, but now we measure around to the second line. And we have to think about what that angle is. Well, if we'd gone all the way down to the horizontal here, we'd have had 180. But we haven't. We've taken a little slice off. How big is that slice, that blue angle there? Well, it's 44.4, as we said earlier. So the real angle we've got is 180 minus 44.4. 180 minus 44.4, which you will expect to be 135.6. And that's our second solution. So that's how to use the cast diagram to get both solutions to this particular equation on this particular interval. Let's try a couple more. Okay, next up, 3 tan x equals 14, and the same interval, 0 to 360. Rearrange to get sine, cos, tan on its own. Well, that's really important here, okay, because tan x isn't on its own, so we have to rearrange that a bit. Well, what we want to do is divide by 3. So to get just tan x on the left, which is what we want, we have to divide both sides by 3, which means we get 14 over 3. Done. Okay. You have to have the trig function on its own for this method to work. Now I'm going to use my inverse tan button to get an angle. And what I'm going to put into inverse tan is 14 over 3. Okay. I'm going to see what angle I get when I do that in degree mode. So 14 over 3, take the inverse tan of that, and you get 77.9 degrees. Okay, done. Step 3, draw lines in the correct parts of the cast diagram. Well, we're doing positive values of tan x. So tan x can be positive in the A section, where they're all positive, or in the T section, where just tan is positive. And the angles, which remember are equal to this answer here, 77.9, those angles are now marked from the horizontal. So we get a 77.9 there, and we get a 77.9 down here. Now we measure our solutions to get our two answers. So the first answer we're going to get for x, we're going to measure from 0, and we're going to get the one our calculator gave us. Well, that's 77.9. So that's straightforward enough. Again, rounded to 1 decimal place. Okay, then we're going to get another one. So we're going to measure anti-clockwise from 0 again, but we're going to go all the way around to the second line we drew. Well, 0 to 180, that would be 180 plus a bit. So it's 180 plus 77.9, not too difficult a sum. 180 plus 77.9. That's going to get us 257.9. So we've completed all the steps of our method, and we've got both of our answers, 77.9 degrees and 257.9 degrees. And if you want to check on your calculator, put in 3 tan 77.9 if you're in degrees mode. You'll get something close to 14. Close to because of the rounding there. 3 tan of 257.9 will also get you a value very close to 14. Okay, so those to the nearest 1 decimal place are the correct answers for x. Let's do one more example. So here we've got 2 cos x equals 1, and I'm just going to rattle through the steps for this question. Get the cos x on its own, that's going to be the first priority. So if 2 cos x equals 1, we can fairly clearly see that if we divide both sides by 2, cos x is a half, or 0.5, okay? So that gives me the value to put into my inverse cos to do step 2 of this method. So inverse cos of a half. And we'll see what I get. So half is 0.5. 0.5. And we'll do inverse cos of that. Well, it turns out that this is exactly 60 degrees. Well, that's handy. I don't even need to round that to the nearest degree. It's got an exact answer of 60 degrees. Brilliant. Now I need to draw some lines on the cast diagram, as I've been doing before. Well, cos x is a half. It's a positive value, so that can happen where all three are positive, or it can happen here where cos is positive. And these ones have to be marked from the horizontal. So that's 60 degrees in there and 60 degrees down from there. So that gets us ready for step 4, which is to measure our solutions anti-clockwise from 0. Remember that that angle there is 60 degrees, as is the second blue angle downward is also 60 degrees. So I start my measuring. I start from 0, I go up to that line, and I get the answer that my calculator gave me. So I get that x could be 60 degrees. Then I get my second value by measuring all the way around from 0 anti-clockwise. Well, what have I got there? Well, I would have a full turn. If I'd gone all the way back to where I started, I'd have 360. But I haven't. I've missed off the last part. So I've gone all the way around, but I've missed off 60 degrees. Well, that means that I've only gone as far as 300 degrees. So the second answer is 300. Okay, and if you do 2 cos 60, you'll get 1. If you do 2 cos 300, you'll get 1, as long as your calculator is in degrees mode. So those are the two solutions there. Okay, so in our next video we will look at how to deal with negative right-hand sides, and as the series goes on we'll look at some other ways that these equations can be changed. But for now, we've used the cast method to solve basic trigonometric equations. Thank you very much for watching.